Good afternoon, everyone. I'm Yiyan. I'm a PhD student at the University of Science and Technology of China. Today, I'm going to have a talk about our work titled Diffusion Models for Generative Outfit Recommendation. And this work focuses on the application of personalized content generation in the fashion domain. Okay, let's start. Fashion plays an important role in our daily life, but many consumers often struggle to assemble diverse fashion products into a visually harmonious outfit. Therefore, outfit recommendation has emerged as an essential task to recommend well-matched outfits. This streamlines the fashion decision-making process. The traditional outfit recommendation has evolved through two stages. The first one is a predefined outfit recommendation. Based on interaction history, this stage conducts outfit level retrieval to retrieve some predefined outfits for users. But it's insufficient to satisfy users' diverse fashion needs due to the limited quantity and diversity of available predefined outfits. Therefore, the second stage, personalized outfit composition, emerged. Based on user interaction history, this stage conducts item-level retrieval and compels the retrieved items into an outfit for users. Although it addresses the limitation faced by the first stage partially, both stages are constrained by existing fashion products. But existing fashion products might not fully align with users' ideal expectations, especially in details such as colors and patterns. So in this work, we propose a new task named Generative Outfit Recommendation. This task aims to generate a set of new personalized fashion images and compile them into a visually harmonious outfit for specific users. With the generated outfit images, GOR could readily retrieve the similar fashion products in the fashion item database or to fashion manufacturers for customization. To fulfill the GOR task, there exist three criteria. The first one is high fidelity. It requires the generated image with high image quality and to be realistic. And compatibility requires the generated outfit to be visually harmonious and appealing. And personalization requires the generated outfit to align well with users' preferences. Since diffusion models has achieved SOTA results in image synthesis, so we think it holds the potential to fulfill the GOR task. Previous diffusion models for fashion synthesis mainly focus on single image synthesis and the alignment with text prompts or other modalities, such as texture or layout. But GOR requires multiple image synthesis and with internal compatibility, and it requires the alignment with users' individual fashion tastes. Usually, the fashion tastes are captured from user information, including interaction history or user features. Based on all these objectives, we propose a diffusion-based model named Diffusion and is instantiated on two tasks. The first one is personalized fill-in-the-blank task. In this task, given interaction history and designated category, this task aims to generate a fashion image to seamlessly complement this incomplete outfit. And the GOR task directly generates a whole outfit. And this is the overview of diffusion, and specifically, diffusion takes the whole outfit as a unit. Here we only illustrate outfit with 4 items, but actually diffusion could handle outfits with arbitrary quantity of items. Generally, diffusion consists of two critical processes. During the forward process, diffusion gradually corrupts outfit images with Gaussian noise. When adding enough noise, this image will approximate to pure noises. And starting from this noise, the reverse process try to reconstruct the original images here. To pursue the three criteria of GOR, diffusion incorporates three conditions in the reverse process. For example, during the generation of this hat, we tell the model to generate a hat in this position through the category prompt, and to ensure the generated image hat to be compatible with other images in the same outfit. We put all the other images into the mutual encoder to get the mutual condition, and this condition will guide the generation process through the element-wise addition. And to ensure personalization, we capture user preferences over hats based on the user interacted hats and to obtain the history condition. And this condition will guide the process through the concatenation operation. Guided by the three conditions, the text prompt, mutual condition, history condition, the model learned to predict the noise added in the forward process, and the model parameters are optimized through the MSE loss between the predict noise and the noise added in the forward process. Although diffusion has incorporated these three conditions to guide the generation process, it has the potential to overlook specific condition information. So here we adopt classify-free guidance to explicitly control the generation process. Here we introduce the classify-free guidance in classical text-to-image task first. We train in this scene, the model parameters are trained under both conditional and unconditional saying here. Here the TXT means the text prompt, namely the conditional saying, and the empty set is a fixed tensor without any condition information. And during inference, the predicted noise under both conditional saying and unconditional sayings are combined to guide the generation process. And the guidance scale is a hyperparameter to control the influence of the condition. And in diffusion, we extend the one condition classify-free guidance into three conditions and introduce three guidance scale to control the influence of each condition. And during inference for the PFITB task, diffusion directly utilizes the clean image to obtain the exact mutual condition to guide the generation process. And for the GOR task, since the exact mutual condition is unavailable, so here diffusion just utilizes the noisy image at each diffusion step to capture the mutual influences within the outfit and to guide the generation process. To validate the effectiveness of diffusion, we conduct experiments on two datasets, namely the iFashion and Polyval U. We compare diffusion with both generative models and retrieval-based models. And the quantitative evaluation metrics, including classical generative metrics such as FID, IS, and CLIP score. In addition, we introduced some fashion metrics dedicated to the GOR task, namely the similarity to the ground truth, compatibility, and personalization. And to compare diffusion with retrieval-based models, we ground diffusion-generated image to existing fashion product and compute the retrieval accuracy and other metrics. This is a quantitative performance comparison between diffusion and generative baselines in both tasks. Here we can see that diffusion illustrates superiority over the fidelity, similarity to the ground truth, and compatibility personalization. And we retrieve proximal fashion products for the diffusion-generated images and compare it with retrieval-based models. And here, diffusion is evaluated in a zero-shot scenario since it is trained without exposure to negative outfits. Here we can observe that diffusion achieves comparable performance to retrieval-based models across various metrics. And particularly, diffusion surpasses all the baselines on the diffusion dataset over the PFITB task. This success affirms the practical feasibility of implementing diffusion-generated images in real-world scenarios through the retrieval mechanisms. We also conduct human-involved qualitative evaluation on Amazon Mechanic Turk through the binary choice tests. The metrics including fidelity, compatibility, and personalization. We compare diffusion with two competitive generative baselines. According to the results, we can see that diffusion is consistently preferred over the baselines across all the evaluation metrics for both tasks. And here are some case studies generated by diffusion. For the PFITB task, the generated images are enclosed in a small box within each outfit. And we can see that diffusion-generated images illustrate superior image fidelity and compatibility. And for the GOR task, we present the user-interacted items and the generated outfit. We can see that diffusion-generated images are more realistic with clean backgrounds, and the outfit is more harmonious in occasion, season, and style. And more importantly, the outfit aligns well with user preference over color, pants length, and the overall sports style. Besides, the PFITB task could be considered as a simplified GOR task. So we can expand the GOR task into a more generalized form. Given user-interacted items and an incomplete outfit, here's an incomplete outfit could be an empty set. And the empty set is equivalent to the classical GOR task. Here, diffusion can generate an arbitrary quantity of personalized fashion items to compose an appealing outfit. And I think this concludes the presentation, and thanks for your listening.